protocols for standard implementation, which means if port 21 is open, it's not enough to send any traffic on port 21, because the protocol inspection engine is going to make sure that the traffic is exactly FTP standard protocol. Otherwise, it's going to block. So if you find specific port open in the firewall, you cannot send your attack within that port if your attack does not comply with the standard implementation of that protocol. This applies to protocol like SMTP, POP3, FTP, DNS, ICMP, NTP, etc. If you want to use a port, the traffic has to comply with the standard implementation. IDS, IPS, they also monitor traffic against non-signatures, and the signatures are updated. Even if your traffic comply with the standard implementation, if they carry non-signature, for example, there is a user field which is a field you can manipulate. If that field contains, for example, a shell code, and this shell code is not sophisticated enough, it's going to be detected by the IPS and IDS. Now, DMZ. DMZ nowadays is part of every network. The interesting feature of DMZ is not the security of the DMZ itself, it's how administrators sometimes overlook important issues with the DMZ. A critical server that's in the DMZ could be allowed to have outbound access to the internet, unlike the servers which are on the inside. For example, as I said, the restrictions are placed on the outside interface and the inside interface of the firewall. Now, for DMZ, sometimes there is no restriction on the outbound traffic. There is no restriction on the ICMP traffic. So DMZ servers can ping outside, can send NTP protocols, etc., whereas internal servers cannot. This is very important for us because if you compromise a server in the DMZ, you can utilize protocol like ICMP or NTP to tunnel your own reverse shell. Authentication proxy is very important nowadays. People cannot browse the internet without proxy, and the proxy makes sure that the users are authorized through their account credentials and so on. So if you compromise a client, and that client cannot go to the internet except through a proxy, you have to make sure that you have the hashes, the authentication credential you can send with the attack, so you can tunnel your attack back to the server, to the outside. So this diagram summarizes the modern network security architecture, the 5 components I just spoke about. You can see the network level firewall behind the inspection engine and the IPS or IDS. You can see the DMZ segment, which is isolated from both the internal and external network. You can see the authentication proxy, which is between all the users, all the clients within the corporate networks and the outside world. Now, let's look at the attacker challenges. How we can view this from attacker's point of view. When we want to develop a world-class tool or world-class methodology for penetration test, we need 3 factors to keep in mind. The first factor, we cannot rely anymore on inbound connections or arbitrary outbound connections. That was in the past. Nowadays, inbound connections are blocked except the needed traffic. Arbitrary outbound connections are also blocked. High ports are blocked. Only the needed outbound traffic or connections can be made. When you want to tunnel your attack, or when you want to tunnel a shell, your traffic has to comply with the standard implementation of the protocols that are allowed through the firewall. Otherwise, inspection engines are going to drop your connection. The last thing, one of the most important aspects of compromising a system is not the exploitation itself. It is to have a persistent access after you exploit the system, which means if you exploit a system and then you have access for a few seconds or a few minutes or hours, and then if there's a firewall reboot by the administrator, you lose your connection and you no longer have access to the compromised system, that's not very advanced. And that cannot stand in advanced penetration tests. So we need a way, when we compromise a system, to have persistent access. We can access it now and then come back tomorrow and after tomorrow, even if there is disconnection in the traffic, even if there are patches installed and so on, you can still maintain that persistent access. So these are the three challenges we need to look at, and the technique of next generation reverse shell addresses these challenges. So let's look at the theory behind next generation reverse shell. Next generation reverse shell provides 5 main characteristics that are not available in basic reverse shell. These characteristics are reliability, maintainability, flexibility, stealthiness, and inspection evasion. Reliability. Once the reverse shell is established, reliability guarantees you to have a continuous access in case of disconnection. For example, if you have a reverse shell connection and then the server reboots or the firewall reboots, there is an auto re-establishment of the connection. There is also keep alive messages that are sent frequently between the client and the server to maintain the session. And these keep alive messages detect any changes, any disconnection, any changes in the server IP, any changes in the server port numbers, and so on. So it's completely automatic. It detects all the disconnections, all the changes automatic, and it readjusts itself automatically. Maintainability. Let's say you establish a reverse shell to a compromised system that are behind a firewall and internal network. And then you want to change the server IP. Maintainability means provide you with a dynamic way to change the IP address without rerunning the program again on the client. So while having the reverse shell connection, you can change the IP address. You can instruct the client to change the IP address and connect to another IP addresses directly. It will just stop your connection, establish the connection with the other server, and you have a reverse shell on the other server. Or, for example, you are having a reverse shell tunnel, let's say in HTTP, and then suddenly you want to change it to SMTP or POP3 tunnel. You cannot rerun the program again on the client. All you have to do is to issue a command from the server to the client to re-establish the connection on the desired ports. These are the means of maintainability. Flexibility. I said before that the current basic implementation of reverse shell, they only provide you with one shell process per connection. You cannot have multiple shells. Now, with the next generation reverse shell, you can have multiple shells over the same stream. When you establish the reverse shell session between the client and the server, you have one shell. Let's say you want to create another shell. You can issue a command, and then you have another shell. Both shells can be accessible through the same TCP stream. You don't have another TCP stream. It is the same single TCP stream, and I'm going to show you a demo for that. It is the same TCP stream. You are accessing 2 shells or 3 or 4 or more. And every shell preserves its own current work directory as well. For example, you can have the first shell working in slash directory, the other shell working under slash boot, and so on. The other feature of flexibility is that you can control multiple clients at the same time. From the single server, it's always listening on more and more connections. Once you have connection from a compromised client to the server, and you are having a reverse shell to that client, you can also wait for another connection from a different client. So you can have one server controlling multiple clients at the same time, and you can switch on the fly between those clients and change your control. You control the client, and then you work on the other client. Stealthiness. Next generation reverse shell provides an option of encoding. You can encode the shell transaction while being tunneled in the standard protocols. This is very important. For example, if you have a command like cat/etc/password and you are trying to dump the password file, you don't want that to be visible in any network sniffer. So encoding provides a good mean of stealthiness. Inspection evasion. All the transaction of reverse shell that's taking place between the client and the server take place within standard protocols. Currently, the protocols implemented are HTTP, POP3, SMTP, and NTP. And in the future, we're going to have ICMP and DNS as well. So when you have a standard protocol traffic, your inspection engine the inspection engine on the client will not drop your connection because it appears completely standard. If it's FTP, you are tunneling with an FTP, there's initial FTP transaction takes place before the reverse shell. So the inspection engine always sees standard traffic between you and the client. Now, let's move to the general technical implementation of next generation reverse shell. There are 5 points here that I want to discuss. Session establishment, executing shell commands, controlling multiple commands, the internal NGRS command system, and multiple shell spawning. Session establishment. Now, given that the protocols that tunnel reverse shell between the client and the server can be TCP protocols like SMTP, POP3, or HTTP, and UDP protocols, for example, like NTP, as I'm going to show you, the way session establishment differ between TCP protocols and UDP protocol. With TCP protocol, you know that the session is established when TCP three-way handshake takes place. However, with UDP, we need additional factor. And with UDP protocol, we implement a customized initialization and acknowledgement packets that take place at the beginning of the transaction between the client and the server, so we can know that the session is established. After the session is established, whether in the TCP way or UDP way between the client and the server, the client keeps sending keep alive message, and the keep alive message are pre-configured way on the client to send those packets to the server, and the server understands that these are keep alive packets. Keep alive packets have two purposes. The first one they maintain this session between the client and the server.